Hi, hi, Aziz.
This conference will now be recorded.
This session, we shall try to implement two use cases, guys. Two programs, two smart, simple programs only. One program we shall try to implement the sorting program, a sorting algorithm we shall try to implement that is called as bubble sort. And one more use case, a simple use case where we can implement some banking transactions like withdrawal operation, deposit operation. Let's try to implement that. Withdrawal, some depositing, balance checking, like some transformations. Okay, we shall try to implement these two use cases in this session. Okay, first let us open this IDE and in this let me go to the project structure. This with the project structure, and in this let me create one more package, guys, here under Scala. And let me get one more package. A package com dot scala dot sorting. I create one separately for package, and I create one more package separately for these use cases. Scala package for use cases. So we shall try to have all the programs under these packages. So first, Scala programming under this. Let us create a new object first. No Scala class, and here we choose object. Let's call the object as sorting. Okay, fine. So we have created one package called as com.scala.sorting. Under that we have created one object now. Okay, now let's write the main method. Main method is complete. Just I will write the first template. Thereafter I will try to we shall try to implement the code there. Okay, args. It need not be always args. I can take something known as a also. Okay, array of string colon units, and here we need to this is one object, and let us create one class, guys. Here under the same package starting only, let me create one class. This is object, the singleton object, right? Okay, and let me create a class under this new Scala class. Okay, so let me call this BubbleSort. Let me call this class as BubbleSort. So this is the, let me close this one. Okay, this is the object which has a main method, and this is the class where we are trying to implement the logic of BubbleSort. Okay, so here we are going to have main, and here we are going to have this implementation of this. So I create method called as here sort, sorry, or called as bsort, to or called as bsort. And what does the input a sorting method has to take? It has to take some set of elements, right? It has to take some set of elements. It has to sort those elements in an order, isn't it? So let us do set of elements into an array. So I call it as input, okay, into an array of integers. Let me take integers, or you can take double or anything whatever you want. Array of integers, this is the input, and output is also again an array, sorted array. Okay, array of int equal to, here we need to implement the logic of how we sort the data, that we have to implement the logic. Okay, and let me write this function. This method is for what? Method for sorting data, sorting the data. Okay, we did not write the logic, just I'm creating a template for it. Okay, this is a class, and in this we have creating methods. Clear, guys? Okay, anything wrong here? Yeah, fine. Let's go here. Now from here we need to make a call to that function. How to make a call to that function? First we need to create an object for that sorry, for this class, for the BubbleSort class we need to create an object first. Okay, how to create object? Well, ob colon, it belongs to which class? Bubble sort class. Bubble sort equal to new bubble sort. This is how we create an object for it. Okay, what is this step? This step is for creation of object, creation of object for which class? Bubble sort class. Okay, remember this is how we create a class, an object for a class. Okay, after the object is created, what we have to do now? We have to make a call to the method of that class. What is the method that we have in that class? Bubble sort. B sort is the method, and what is the input it is expecting? It is expecting an array as input. Okay, it is expecting an array as input, and the method name is B sort. So we access that by using like this: ob dot sort, not sort, B sort. B sort of, here we need to pass an array as input, an array of integers as input. Okay, let me call this array as a. Let me call this as a. It's an array of input, or let me take a arr as an array. Okay, and if we pass an array, see this function, see this method here. This is the input. This is the input we are passing, array of integers, and what is the output we are expecting here again? The output is also an array, isn't it? The output is also an array. So we have to catch that array now here. We say life like this: val result colon array of, this is right now. Consider carefully, guys. Not array of string here, array of integer. What I'm trying to write here, just consider carefully. Okay, so result colon array of int equal to ob dot sort of array. And what is this statement is doing in other words? Okay, calling the method b sort of bubble sort class. Okay, bubble sort class. Okay, calling the method b sort of bubble sort class. Okay, by using this object reference ob dot b sort of array, and we need to create an array here, and we need to pass that array there. So how do we do it? Very simply here, right down here, println enter an array size, enter an array size. Okay, while size yes colon, otherwise I use s colon int equal to scala dot io dot scala dot io dot stdin dot read int. So with this we get the size of the array, okay, into s. Now we have to create an array val arr equal to new array of int of, what is the size? Yes, this is how we create an array with the given size. Okay, with the given size. After that we need to enter the data of array. We need to enter the elements of that array, isn't it? After that we have to pass that array to this method b sort method of the class bubble sort. Is it fine? Now ask here for I, so starting with 0 to s minus 1, isn't it, by 1. So 0 to s minus 1 by 1, what we have to do here? We have to accept the data. Okay, println enter which element? Enter the first element. First element in the sense I plus 1 element. Okay, plus I plus 1 elements. Enter the first element, or no, enter element, and after this val a of I, not a, is not a arr, I equal to scala dot io dot stdin dot read int. We don't have val here, directly array of array. We will not have array. Okay, so this statement is for what is this statement, guys? For the reading the size of the array. And this creates, what does this statement create here? It creates, this statement creates an array of size. What is the size? Yes here. Okay, an array of size yes. Okay, now, and after this, what does this statement, this loop is doing here? Reading the elements of the array, elements of the array. Okay, with the statements. And finally creation of object of bubble sort, and we're passing that. Now can you tell me, okay, this is the main method. Okay, here we are reading the array of the size of the array, and the creation of array with the given size, and this is the loop for reading the elements of the array. And ob1, so with the array, whatever the array that is created here, arr is the array, so that array we are passing to, where we are passing that array to, we are passing that array to bsort method of ob. What is this ob? Ob is a reference to which object? The object of the class BubleSort. Okay, so whatever the array we create here, that array will be passed to bsort in the sense here. Okay, now here we have to write the logic of sorting the data, but we have read the logic of sorting the data. Is clear, guys? This is how we have to write the code. First to write the skeleton part, and later implement whatever that we have to write in the code. Okay, we have to develop the code. Okay, first develop a skeleton, then implement that skeleton part, whatever we have to write the code. Okay, remember that part. Okay, now this part is done, and finally we can write like this. Okay, so now can you tell me, after this code is done, uh, which variable will be referring to the output? Which variable will be referring to the output finally in this code? If you go through this code, can you tell me after this, which variable will have the output? Yeah, guys, which variable is going to have the output? Yeah, Raviteja, arr, is it arr?
Results, sir.
Result, it is result. Okay, remember guys, it is result. Okay, so this statement, it returns an array. It returns an array. This is right? This is what it is doing. It is returning an array of integers. Okay, and we are assigning that to result. This result will have the output. Okay, finally we can write like this: println the sorted data is what is the sorted data? Now it would be plus result dot make string of by using comma. That's fine. Now we have to implement the logic, guys. Here everything is fine. Now we have to implement the logic here. So how do we implement bubble sort? How do we implement the bubble sort? That's our question now. How we have to implement it? What is the logic? So I will explain the logic. Based on that, we shall try to implement it. Okay, so now how to implement this? See this, let's take some random elements, some 20, 12, some 6, 42, 39, 67, 72. Okay, let me eliminate these elements: 1, 2, 3, 4, 5, 6, and total 7 elements. Okay, how this bubble sort is going to work? Very simple. We take the first element. So index of the first element starts from 0, right? 0, 1, 2, is 0, 1, 2, 3, 4, 5, 6. What is the number of elements here totally now? 7 elements. That is, let me take n equal to some 7. There is number of elements equal to 7, and the index of the last element would be equal to 6, isn't it? This is fine. Okay, now starts with 23. Compare 23 with 12. Compare 23 with 12. So which is the larger element between these two? 23, isn't it? So now swap this 12 and 23. Okay, now this is done. Next, compare 23 with 6. So which is the large element between these two? 23 is again larger than 6. Now again swap these two. So what do we get from this? 12. This we won't touch this again. Now 6 and 23. Swap these two. 6 and 23. Swap this. Now these two are done. Next to 23. What do we get? 23 and 42. Which is larger between these two? 42 is larger. So do not swap it. Do not swap them. Let it be as it is. Let it be as it is. Okay, fine. Next, 42. Next, take the element 42. 42 with 39. Which is larger here? 42 is larger, right? 42 is larger. So now swap this 42 and 39. So we get 32 here, and 39 here, and we get 42. Okay, with 39 and 42. So again 42 plus 67. 67 is larger than 32, 67, 42. So let it be 67, and next compare 67 and 72. So 70 is larger than 67. So finally 72 will be in the last position. Okay, what we do is actually start from the first position element. Start from the first position element, and our intention would be to, yeah, our intention would be like this. The intention is to move largest element to the largest element to the last. Okay, this must be our target here. So every time, for every iteration, what we do is bubble out largest element to the last position. That is called as bubbling out the largest element to the last position. That's the ascending order of element data, right? The ascending order of the elements, right? Bubbling out the largest element to the last position in the list. This is what we have to do. Okay, so if I start with 23, if you go on comparing what has to be the last value, that must be 72. It will be 67. Then after that, what we have to get? We have to get 42. We have to get 39. Like this, it is going to happen. Okay, see this, guys, it's very important. Start, see this one. Okay, let me explain again this one. Let me erase this. What is that we are trying to do? Just observe here. So our target is to move the largest element to the last position. So how do we move that largest element to the last position? See this now. Okay, so what is our target? Is how many? 1 2 3 4 5 6 7. So we have to move with 7 iterations, 7 times, with 7 iterations. Okay, so in the first iteration, let me take this as 7, or let me take this as 7. Let it be not 72. Let me take it as 7. Okay, so in the first iteration, 67 must go to the last position. By the end of the first iteration, 67 must go to the last position. Okay, now, and by the end of the second iteration, which is the next largest element after 67? 42, right? So we should have 67 by the end of the next iteration. We should get 42 here. Okay, next, by the end of the third iteration, what we have to get is this will be unaltered, this will be unchanged, 42 and 67. And what the next element, next largest element after 42? That would be 39. So we have to get 39 like this. Okay, and after the fourth element, fourth iteration, what we have to get? 67, 42, 39. And what the last largest element next to 39? That will be 23, isn't it? 23. By the end of fifth iteration, we have to get 67, 42, 39, 23, and after that, what do we have? 12, right? It is 12. 12. And by the end of the sixth iteration, we have to get 12, 23, 39, 42, 67. And what's the other element we have here now? After 12, we have 7. We have to get 7 here. And finally, seventh iteration, we have to get here 6, 7, 12, 23, 39, 42, 67. This is how the data we have to get started. Okay, so for every iteration, what should happen is the largest element must move to the last position. So by the end, by the time we complete all the tests, we have 7 elements. By the completion of 7 iterations, all the elements will be in the sorted order. But how do we move the largest element to the last position? That is the task. That's what we have to do here now. Okay, so is this clear, guys? First, remember the first, try to understand this one. For every iteration, for every attempt, the largest element must move to the last position. Is it okay now? Just we did not implement any logic how to move it. Just I'm telling you, this must be our target. So now we have to write something, some logic in order to move the largest element to the last position. Okay, now no, this is not efficient way. It's not efficient way. Still we have what you call as many sorting algorithms are there. This is only one of the sorting algorithms. Every day we shall discuss one sorting algorithm. Today we have discussed bubble sort. Tomorrow we shall do one more sorting. By the time we complete some 4 to 5, we'll discuss what would be the which would be the best sorting what you call as the sorting algorithm. Okay. Now let me take all these elements. How this is going to be for each iteration, how the data is going to be executed. Let us see this now. Is it clear, guys? First, okay, for every iteration, the largest element must move to the last position. Okay, let me take these elements: 23, 12, 6, 42, 23, 12, 6, 42, and three more elements. What are they? 39, 67, 7. 39, 67, 7, guys. Okay, now what we have to do is, what now we are performing the first iteration, first attempt. What should happen by the end of this? What should happen, guys? 67 must come to the last position. Why? Because this is the last element. How do we do it? Very simple. This compare first two elements. Compare first two elements. Which is the largest element between these two? 23, right? Now swap this. 12, 23, 6, 42. The remaining elements will be as it is. We won't change them. Okay. This is done. This is done, guys. Next, now compare 23 and 6. Which is the largest element? 23. Now swap them again. So 12, 20, 6, 23, 42, 39, 67, 7. These two elements are done now. Do not touch them. Now compare 23 and 42. Which is larger? 40 is larger. So do not swap anything. Just let it be. Let the elements be as it is. 12, 6, 23, 42, 39, 67, and 7. Now these elements are done. Next, compare 42 and 39. Which element is larger? 40 is larger than 39. So now swap these two. So 12, 6, 23. Swap these two now. 39, 42, 67, 7. This element is done now. Up to here it is done. Next, compare 42 and 6. Which is larger? 67. So let it be as it is. So do not swap. Now it will be 12, 6, 23, 39, 42, and 67, 7. Now compare 67, which is larger? 67 is larger. Now swap these two. So it would be 12, 6, 23, 39, 42, 7, and 67. Thus done. By the end of the first iteration, 67 came to the last position. That's it. This is one iteration, guys. Only one iteration. Is it clear, guys? Now is it fine how we are sorting, how the data is getting sorted here? Any questions in this, guys? You know what, we are not doing anything, right? Simply comparing the adjacent elements, and if the left side element is larger than the second right side element, we are swapping. Otherwise we are not swapping anything, and we are proceeding to the next position. What is the position here? First element is position 0. Okay, so after this is done, this is a position, right? 0, 1, 2, 3, 4, 5, and 6. Okay, so we are starting with 0, comparing 0 and 1 first. After that we are comparing 1 and 2. After that we are comparing so I think sorry, here we are comparing 0 and 1. Here we are comparing 1 and 2, and here we are comparing 2 and 3. Here we are comparing 3 and 4. Here we are comparing 4 and 5, 5 and 6. That's it, nothing else. Finally we have 6 only. That's it, done. Okay, so we're comparing 0 and 1 here, 1 and 2 here, 2 and 3, 3 and 4, 4 and 5, 5 and 6. That's done. Okay, is it clear, guys? Finally, okay, this is how we have to implement. Okay, after this is done, and again where from we have to start the process again. Only one. By the end of the first iteration, how many elements got sorted now? Can you tell me, guys? After by the end of the first iteration, how many elements got sorted? Yeah, you have to tell me, guys. Only one element, that is nothing but 67. Okay, we have 67. Okay, and where from the process starting from? The process starting from the zeroth position and ending with the last position, that is 6. This is important, guys. The first iteration is starting with the process starting with 0 and ending with 6. Okay, now is it clear, guys? Now let's go to the second. So this is the status of the elements after the first iteration is done. Okay, also this is the status. So now let me copy the second elements: 12, 6, 23, 39. 12, 6, 23, 39, and 42, 7, 67. 42, 7, 67. Now, do we have to touch the last element, guys? This need not be touched now. We need not to touch, we need not to include in the iteration now. Why? Because it's already started. So still the positions are like this: 3, 4, and 5. Okay, now where from our logic starts execution, guys? Now this is the second iteration. This starts with 0. So compare 0 and 1, which is larger? 12 is larger, so swap these two: 6 and 12, 23, 39, 42, 7. Do not touch this. We need not to touch the 67. Let it be as it is. Okay, do not touch it at all. Okay, now after this is done, 0 and 1 are done. Now compare 1 and 2. 1 and 2, 12 is less than 23, so no need to swap it, is write them as it is. So this is done. Next to 6, 12, these two are done. Next to 23, 39, 42, 7. Need not to touch this. Next again compare 23 and 39, second element, second position and third and fourth positions. So again 23 less than 39, so no need to swap, let them be as it is. 12 and 6. By the time these three are done, next again compare 39 42. Still again 39 is less than 42, so it will be like this. So even this is done now, and again 42, 7, and 67. 67 will be as it is. No need to touch this. And finally compare 42 and 7, which is larger? 42 is larger. So swap these two: 7, 42, 6, 12, 23, and 39. These are done. That's it. Now 42 and 67. So by the end of the second iteration, what did we get? 62 already got started. Now 42 also got started. Now 42 also got started. And where did we stop our process now, guys? Where did we start our process? We started our process with 0 and ended our process with what? What is the index now? Index of 48. This position element. What is the index of this position? It is 5. Okay, for the second iteration. Clear, guys? So second element got started. Likewise, how many iterations we have to perform? So by the end, so in the first iteration, the index of the elements we have considered for processing is 0 to 6, and the last one element got started. Okay, last element. Second iteration, our processing starts with 0, ends with 5, and two elements gets processed. And by the end of third iteration, 0 start with 0, end with 4, so we get 3 elements will get started. And by the end of fourth iteration, it starts with 0 and ends with 3. 4 elements get started with this. And the fifth iteration, it starts with 0, ends with 2, so 5 elements will get started. So sixth position, 0 to 1, 6 elements get started. By the end of seventh, 0 to 0, we have only one element. Totally 7 elements will get started. That's it, guys. This is how the logic is going to work. Okay, now we have to implement this logic. Fine, is it clear, guys? So how, writing this logic in a program, as a program, we should, if we understand the programming, if we understand the logic clearly, then and writing the program is also a not that easy. We should understand what the logic, what functionality, or what concept in the program we have to apply to get the result. Now can you tell me, yes, the number of iterations? Now how, so totally how many iterations we are performing, guys? First, 1 2 3 4 5 6 7. So totally 7 iterations. Okay, 7 iterations. And For each iteration, how many we are performing iterations we are performing? How many times to what are the elements in the range on which we are performing the logic here? 0 to 6 means how many elements for the first iteration 0 to 6, that is if the number of elements are 7, right? So 0 to 6, there's nothing but all the elements. Okay, so for this we write the logic like this, guys. Just I will write the logic here. See this: for some I starting with 0 to s size minus 1, there's nothing but what? Yes, up to the last element. If the number of elements are 7, up to 0 to 6, initially 0 to, we have to perform this for 7 times, right? 0 to 6 nothing but 7 times by 1. What we have to do now, guys, again for each iteration, what we have to do again, we have to write one more loop here for starting with I some k equal to, where from we have to do this, guys? Now where from we have to do this? 0 to 0 to where? 0 to for the first iteration, up to where we are doing this logic, up to where we are what the up to what element we are performing this logic here? 0 to, yeah, you have tell me, guys. 0 to, you know, number first iteration, second iteration, third, fourth, 5, 6, 7, so the value is getting increased by 1. And for last we don't have to yes, don't to perform that would be n minus 1. That's what I'm telling. For k equal to 0 to where we have to perform the logic here, up to where? K, one more in that we have to write one more loop up to where we have to perform the logic. In the first iteration 0 to 6, second iteration 0 to 5, third iteration 0 to 6, 0 to 4, 3, like this. It should end with 0 to 0. Then we have to where we have to do this, guys. Okay, so shall I take from 0 to s minus 1? Okay, s minus 1 only, but by minus 1. Can I write like this? K equal to 0 to s minus 1 by minus 1. By minus 1 in the sense, next iteration would be from first iteration would be 0 to 6, second iteration would be from 0 to 0 to what? By minus 1, right? By minus 1, that would be from, sorry guys, this is not up to minus 1, 0 to not minus 1, 0 to what's the thing here? Not 0 to s minus 1, first 0 to 6 followed by 0 to 5. How many times you have to perform the logic here? 0 to s minus 1 by 1. No, we shall take like this, guys. Let me just check up. Already have written the logic. I have to forget the logic. Math scala, binary search, bubble sort. Sort, B sort. Yeah, k plus 1 to s minus 1. Yeah, this is what I have read actually. This is a logic guide. K equal to 0 to s minus 2 by 1, and I equal to k plus 1 to s minus 1 by 1. You got and you understand the logic, right, guys? Here, how we are implementing this logic, you understood, right? The logic you understood, right? Okay, this is the code. I write the code here. Just see this. So what I do is I copy the logic here directly. The logic. Enter the element is done for up to here. Copy this. It will be for some k equal to 0 to s minus 2 by 1, and k plus 1. Okay, we have to perform two operations. What is s here, guys? Is the size of the array, right? Val s equal to input dot size. It is not ARR here. Let me take this as ARR. Just when you have time, just to go through this code, okay? If you understand the logic, you can understand the code easily. I may take some temporary variable. What is the temporary variable? Some temporary equal to 0. Copy this. Mm, mm, Something wrong. What is it? What is the error? Equal to 0. Where I int equal to 0, where s equal to error dot size. Should I debug the code for loop to understand better? Yes, we can debug. Not a problem. S minus 2 by 1. For equal to k plus 1, s minus 1 by 1. If I have k greater than array of I. Okay, t equal to array of I and array of I equal of k, array of equal to t. I think one more brace is required. Yes, one more brace is required. This is fine, guys. I think this is the logic for perform the bubble sort, and this is from where we are submitting the what we call as input, guys. Okay, so if we run this program now, let's run this program. Run sorting. What is that? Missing brace. How many we have here? Bubble sort is the class, and a df bubble sort 1, 2, 3, 1, 2, 3. One. Do we have an extra here? 1, 2, 3, 4. So I think we need to have one more. I will send this code to you guys. Okay, I will send you this mail, this code to you. Have a practice of. Just go through it. You understand. Type mismatch found. You don't require array of int. Where is it? In s2 by minus 1. Yeah, here we need to finally this is a loop 1 2 1 2 final return arr. That's it, guys. Nothing. It has to work now. One second. I think I found a unit required array of int. This is the function. This is the method. I think this must be out of this. Enter the array size. Some 5. First element 23, 12, 3 or 4, 56, 32. So the sorted as 4, 12, 23, 32 and 56. Okay, clear, guys? Let me run once again the code. Let me enter some different elements. Enter the array size 7. First element 12, 2, 34, 3, 44, 4 and 55. 2, 3, 4, 5, 12, 34 and 44. It's clear, guys? Just go through this code. The logic is fine. If you understand the logic, understand the code is not that tough. Just go through this code, you'll understand. Okay. Fine, guys. Okay, no. I'll send you this code. Just go through it. Okay. So this is about implementing the bubble sort program using Scala. So in the interviews, guys, they're asking the questions about Scala programming, how to write the code, how to make a call to the function, how to make a call, how to create a class. These are the questions they're asking interviews. Okay. So don't just ignore. Understand the logic is one step, and implementing that logic in a program is another step. Okay, it's not that easy. It's not that easy. Okay, understanding logic is fine. Anyone can understand the logic, but implementing it in coding is not that easy unless we have the idea of coding and where to place these braces, what is the return type, everything. You have to understand the syntax and everything of the program. Then only we can do the coding easily. Otherwise, it becomes tough. Okay, na? Clear, guys? Okay. Now, this is done. Let us implement one use case. Just now I have shown you, right? In the beginning of the session, I made that point that we shall discuss about some banking use case. I will try to implement two functions. Remaining functions you try to implement, guys. Okay. I will try to implement one or two or three. Remaining you try to implement. Okay. Now, what I do is we have to create a customer, and initially some amount. The customer will deposit some amount into the what you call as account. It's into his account. So we need to write the methods for performing deposit operation and withdrawal operation. Deposit, withdrawal, and third is uh, balance. Let me say balance. So remaining, what do we calculate the remaining stuff that we can implement? But I will try to show you deposit. How do we deposit? How do you write a method for deposit, method for withdrawal, and method for balance? Okay, these three we are going to implement. Okay, now let's try to see how we are going to implement this. Very easy, guys. Very easy. So under use cases package, let me create a new Scala object first. So let me call as banking. And next under this, let me create a class, new Scala class, banking transactions. Banking transaction. It is a class, okay? So in this banking transaction class, we have to implement three methods. One method is deposit. Deposit. So when we are asking for a deposit, we enter some data, right? So we have to pass some data. How much you want to deposit? That figure has to be specified, right? Amount, deposit amount. So it will be. Should we take as integer, or should we take as should take it as long? Okay. So after deposit, what has to be the return? No, a statement will be given to that. A slip will be given to that. A message will be thrown to that. This is the balance after you deposit the amount. Okay. So again, return also will be long. Okay, and we have to write the logic in this. So we shall see the logic later. First, let us write the skeleton of the program. Okay. Next operation is withdrawal. Withdrawal, and how much amount you want to withdraw. Even that we have to enter, right? Let me take everything as long. And after withdrawing is done, again we have to display the leftover balance, isn't it? So for that we have to write one more. We shall implement the logics later. And next one more method. What is that? Balance. Balance check. Balance check. So here we don't enter anything. We don't enter for balancing check. We don't enter any amount, right? Simply we check balance. That's it. It is going to give us the balance. So we say that it is simply long. That's it. We have to implement. Now we have to implement the logics guide. Okay. Now what we have to do is in the object. Let's create main method, and let's what we have to do now here. We have to first create an object of that class, the banking transactions class. So val ob equal to To which class this belongs to? This object belongs to banking transactions. Banking transactions equal to new banking transactions. This object we have created, and with the help of this object we need to call the methods. Ob dot. The first method is a deposit. Deposit of some amount. We shall see the deposit amount. Deposit. Deposit amount. And it is going to give an output, right? It is going to give an output. So let us copy that into bal after deposit. It is long again. So we are returning long there. So it must be long. Okay. And after this, we shall write here ob dot withdrawal. Some amount. Withdrawal amount. And it will return again the balance, right? After balance after deposit, now balance after withdrawal equal to, it must be again long. So we're returning long right there, so it must be long again. And finally, balance check. ck equal to ob dot balance check. We need not to pass anything, directly we get the balance check. And again, even that is long. Okay guys, fine. So we are printing the data like this. Now what we have to do now is, first we have to provide here deposit amount and withdrawal amount and balance check. So how shall we pass these values? So shall we implement this as an infinite loop? Shall we implement this as infinite loop? How do we implement this as infinite loop? Yeah guys, how do we implement this as infinite loop? So before that, we should write the logics here. The deposit. Okay, deposit amount. So what is the deposit amount, guys? Here, after deposit some amount in deposit, that must be added to the already existing balance, isn't it? Whatever the amount we deposit, that must be added to the already existing balance. Okay, you agree with this, right? Okay, existing balance. So how do we write it? That is var total balance after what you call as depositing equal to, it must be equal to existing balance, okay, plus amount that is deposited now, okay, and return total underscore balance. Don't worry about all these errors, we shall see about these errors later. Okay, total underscore balance. Next, later here, after we withdraw something, what has to be done now? Where total balance. After that is done, after, how do we calculate total balance? That is existing balance minus amount that we are withdrawing, isn't it? From the existing balance we have to withdraw the amount, that is going to be the total balance after withdrawal is done. Okay, and what about this? It is simply balance, that's it. It is simply balance. So return simply balance here. That's it, nothing else. Simply return the balance amount that we are going to get. But where from we get this balance amount? Where from we get this balance amount? Okay, where from we are going to get it? Okay, this is important, guys. Where from we get it and how do we do it? Is the logic correct, right? Okay, so when you deposit the amount, that deposited amount must be added to the balance. And when we perform withdrawal, the deposit withdrawal amount must be subtracted from the existing balance. That would be the total balance after it. And for balance check, simply we have to return the balance, that's it, nothing else. Because these are logics to be implemented here. Okay, and how we get this balance value first? Where from we are going to get this balance first? How to get the balance value? Where from we are going to get it? And what about the balance? Is the balance will remain same or the balance going to change every time? Okay, the balance will change, right? The balance will change. Okay, here we're not trying to implement with the database directly, just we're trying to implement here itself. We're not taking the help of any database here. Okay, now Let's implement this with a infinite loop. While true, while true, right? This is how we implement infinite loop. While true, now here, what is the transaction you would like to implement? Okay, println, enter, uh, otherwise first, let us display the options here. First option is deposit and plus slash t, not this one, uh, slash n plus 2 withdrawal, AWL, and plus slash n plus balance check. Next, right here, println again, mm, enter your choice, enter your choice. So the choice must be an integer. Okay, so for deposit you enter choice 1, for withdrawal you enter the choice 2, and for balance check you enter the choice 3. Enter the choice 3. Okay, now what is that we are going to do with this here? So after that, after we enter some choice, if it is 1, this depositing statement has to be executed, otherwise withdrawal something. Okay, now case, if it is 1, if it is 1, what has to be done now here? If it is 1, case 1, because case 1 in the sense it is deposit, right? Now right here, println, enter the amount to deposit. So read the data into val deposit amount colon long equal to scala dot io dot stdin stdin dot read long, where we have long, read long. Okay na? So after that this statement is going to be executed. That's it. That is done. This is about the first case. Enter your choice. First we have to read the choice here, guys. Well, ch colon int equal to scala dot io dot stdin dot read int. Sorry, let us read int and match e match not v, sorry, ch, match ch in that. This is what we are trying to implement here. Fine. If it is case 1, this is the one. Case 2, if the option is 2, what we have to do now? And again, writing here, println, enter the amount to withdraw. We want to withdraw. So we enter it. So val withdraw amount, not shall, val withdraw amount. Is it withdraw amount? Withdrawal amount colon long equal to, that we read from the console, io dot stdin dot read long. Okay, this is the second one. After that, implement this logic. This logic. Okay, and finally case 3. It is case 3. What is that? Since case 3 is nothing but simply what? It is simply entering that, right? Just getting the balance. That's it. and you can write printf statement here. After this is done, printf statement here, println the balance after deposit is, what is the value, that is plus balance underscore deposit. Okay, and here after println, after this print that output, println the balance after withdrawal is plus balance underscore withdrawal. Fine. And after this, for this third case, where it is we are looking for only balance checking, so we get the balance data and finally print println the balance is plus uh, balance underscore check. This is, guys, this is what we have to write here. Okay, so it's something, it is showing double, maybe it must be in double quotes, I think. Yeah. Mm, so val ch match ch, mm, something is showing some error here. What is that? Case classes expected. Case class we have written, right? Match is ch. Mm, case 1, case 2, case 3. Is it right or anything mistake? Oh, ch. In no, it's not in. Nothing match ch. It's not. Mm, something wrong. What is that? Match case. This is done. Match one must stay. Finally, let me write one more thing here. Last case underscore. Underscore is something like default case. Other language we use default. In Scala language we use underscore. Okay. For remaining all the cases other than 1, 2, and 3. Println bad choice is not 1, 2, or 3. If any other than this bad choice. Okay, just simply bad choice. That's it. Mm, either ch match or match ch. This is fine, guys. Okay, we have tried ch match. This is fine. Is the number of braces okay here? This is a base for match, and this is a closing brace for what? This is a closing brace for match. I think this is a closing brace for a while, and we will require one more. This is fine. And coming to this, here we have balance plus amount. How shall we get this balance data? Initial data. Should take initial balance data to 0. Let me take var balance colon long equal to 0. I think this will work. Okay. Now let's implement this, guys, once. Let's see what is going to happen. Run banking. So it gives three choices: one withdrawal, one deposit, two withdrawal, three balance check. I go with one. Enter the amount to deposit, some 1,000. So balance after deposit is 1,000. Okay, and I go with one more again, the same with deposit only. Again one more 1000. Now what does the deposit? It is showing 1000 only, right? The value must be updated. So it's not working. Fine. We have to update that balance. After that is done, mm, this is balance, BAL equal to balance, and this must be balance only. I think this will work now, guys. Let me run this. First option 1 7,000. Next again 1,000 again. Now the balance has to be 2,000, isn't it? Yes, balance is 2,000. Again I enter one more 1,000. Now balance is 3,000. Now I choose withdrawal option. Enter your choice is 2. Enter the amount to withdraw. So if I withdraw from 3,000, if I withdraw 1,000, the balance has to be 2,000, isn't it? Let's see what happens. Yes, no, the balance of withdrawal is 2,000. I enter my choice again 2. Again I withdraw 1,000. Now the balance has to be 1,000 after this. Okay. Now I perform withdraw balance deposit again. I deposit 2,000 now. So the balance is 1,000. Now the deposit 2,000. The balance has to be now totally. Let me go 4,000. It has to be 5,000 now. That's the balance of 5,000. Okay. Now I check for only balance. The third choice. Balance is 5,000. Clear guys how it is performing. Now finally I choose one more choice other than 1 2 or 3. I'm choosing another choice. It's saying that bad choice. Select another choice. Select the choose the choice again. Okay. So we have to select some choice again. To amount to withdraw out of 5,000, if I withdraw 4,000, the balance has to be 1,000 again. We choose third, the balance has 1,000. Is it fine, guys? No, it's not totally implementation of the banking application. Just I'm trying to show you the skeleton, how we can implement, what is the logic, how we have to write it. It's clear, guys? So to execute, to terminate out of it, I can choose one more option. Fourth option, to terminate, I can choose plus fourth option, terminate or close. So what I can do is here, after this I can write case 4. So if it is asked for termination, system dot, you can write like this. If it is chosen, let me write below this, system dot exit 0. That's it, guys. Okay. Now if we run this, initially what would the balance, guys, before applying withdrawal or but call as this one. If you try to see, if you enter withdrawal amount greater than balance, yeah, that condition we have to include. Third, balance is 0 initially. 2, amount to withdraw. The balance is minus 10,000. We should not get minus 10,000, right? That's not possible. So we have to make that correction here. So process exited now. What we have to do now in the withdrawing, if the balance is uh, balance, and here we have to write a condition here. If uh, balance minus amount is less than 0, what we have to do here now? If the balance amount, we have to make a check first, right? If the balance amount, existing balance and amount that we have requested, if the difference is less than 0, then we should not allow to withdraw, right? Isn't it? We have to print something. What is that? We have to print that insufficient amount or insufficient funds. Okay. So print, if it is something like this, println insufficient funds, insufficient funds, and simply return a value. Why? Because we have written some long value, return 0. I think this has to work now. Let us see. Run banking. Error code, we return error code, right? If it's in the case error code, the error code we are returning as 0 here. So initially balance is 0. So mm, let me insert some 1000. Okay, now if you try to withdraw 2000, so it is going to be insufficient funds, isn't it? That's to share. So the balance after insufficient funds, and it should not throw this, the balance, it should not throw this one. Even this message we should not get this message also. Balance after withdrawal we should not get minus 1000. Insufficient, we should get simply insufficient funds. So let me cancel this again. So in the code here, after this is done, if you have to write a condition here, if balance underscore withdrawal, I can write directly like this here. Mm, I don't write here, I write there itself. It is less than 0. Balance only. If balance minus amount is less than 0, okay. If balance underscore withdrawal is less than 0, is less than 0, what we have to get now here? Println println insufficient funds. You can write insufficient funds here. Okay, na? And we should not write this. Else, if the balance is otherwise, we have to print the balance out withdrawal is plus balance underscore withdrawal. Okay, now let's run this now. Enter your choice 1000. If you're trying to withdraw term 2000, that's insufficient funds. Okay, now enter one again, 2000. So the enter the amount deposit. We have deposited 2000, right? How come it is only 1000? It must be 2000. How come we got only 1000 here? Withdraw 2000 insufficient funds. That's okay. How come we got 1000 again? Something wrong here in the deposit. In the deposit, what we are doing here? If balance equal to balance plus amount, and we are returning balance. If balance is amount less than equal to 0, return balance. You have to write else party here. Else. This has to be written here, guys. Now it will work, guys. Now it will work. So still, if you want any modifications or changes, you can add those modifications. Okay. Just I'm trying to show you how to write how to with the schema. Actually, the schema or the skeleton, how to implement it. Some 1000. Next again one more I enter 2000. So 2000 don't is fine. Okay. And if we try to withdraw now 3000, what is the output? It has to show insufficient funds. So it is showing that balance is still the balance is 2000 only. Not a problem. You can change the message in this. You can change the message instead of writing after withdrawal, you can write simply the balance is 2000 only. You can write some message there and you can modify the code. Okay, not a problem. If you check with the balance would be again 10,000 only. Is it fine, guys? And 4, close the application. That's a process finished with exit code 0. Clear, guys? Any questions in this step? You can implement a lot. Still, again, we can implement in the lot of the things in this here. But just I give you a simple skeleton. If you want, you can implement something on your interest. Okay. How exceptions are handled in Scala? I say return without. Yes, I will show tomorrow in next session how we handle exceptions. I will show guys. Exception is very very important topic. Very very important. Okay. So compulsory a program should contain exceptions. Instead of using if cases, write if statements, all this, we have to write the exceptions. There are some built-in exceptions are there. Custom defined exceptions will be there. So let's discuss them. Okay, let us first see the simple programs. Later we shall try to include the exceptions. I will show you guys. I will explain everything. Slowly, topic by topic. In this session, we have discussed about these cases. How to implement the case concept here? Okay, match and case. You have to understand. I don't say exactly that we are right discussing about case. You have to understand that this is how we use cases concept of using, and this is implementing infinite loop. Any material to refer back the programming and so we come with there are many books online. There are many books, online books are there. You can go through them. Many books are there. Many books are there for free download. You can download and go through them. Okay. They can only provide the basics as syntax. They don't provide sample programs. They don't provide any they provide only syntax and the concept. That's it. It's our responsibility to build the programs. Okay. Here guys. Thank you guys. We shall resume tomorrow the session. Tomorrow we shall see one more use case and one more sorting algorithm if possible. Okay. No? Thank you guys. Thanks for your time. Thank you. Good night.